Okay, so kanina we had gaseous state, right? And then ngayon, liquid state. Okay? Now guys, bakit natin to discuss first? So after liquid state, guys, we will be having properties of simple mixtures. So syempre, yung mga individual gases muna, liquids muna, bago tayo mag-delve into our mixtures and phase equilibria. Okay? Let's understand each phase of matter first before we begin discussing the mixtures. So for today, we'll be discussing transport phenomena of liquids, vapor pressure, viscosity, and surface tension. Ayan, Gina, guys. So for the transport phenomena of liquids, there are three parameters. First is diffusion. In diffusion, guys, matter is being transported. Hi guys, welcome back to Physical Chemistry Crash Course, and we're down to our last crash course for FreeChem, and that is on your special topics. Yay! So congratulations guys, you're almost done. So, supported, right? It refers to the movement of solute from high to low concentration. Hi guys, welcome back to Physical Chemistry Crash Course, and for today we will be having crash course 6, the liquid state. Okay, so kanina we had gaseous state, right? And then ngayon, liquid state. Okay? Now guys, bakit natin to discuss first? So after liquid state, guys, we will be having properties of simple mixtures. So syempre, yung mga individual gases muna, liquids muna, bago tayo mag-delve into our mixtures and phase equilibria. Okay? Let's understand each phase of matter first before we begin discussing the mixtures. So for today, we'll be discussing transport phenomena of liquids, vapor pressure, viscosity, and surface tension. Ayan, Gina, guys. So for the transport phenomena of liquids, there are three parameters. First is diffusion. In diffusion, guys, matter is being transported, right? It refers to the movement of solute from high to low concentration. Okay? And this movement is governed by Brownian motion. So when we say Brownian motion, it is the random and continuous motion of particles or molecules as they are suspended in liquids. Meanwhile, thermal conductivity is also another transport property, and it measures energy. So it can see if the material can conduct or transfer heat. Diba? The types of heat transfer include conduction, and radiation. Lastly, in transport phenomena, we also determine the viscosity. So here, the transport quantity is momentum. Bakit momentum? Because when we say that particles have a momentum, they have a mass. Okay? And now, this refers to the resistance of liquids to laminar flow. So guys, when we say laminar flow, it pertains to smooth flow of liquid in layers, meaning smooth yung flow ng liquids kapag naka-layer siya. And pag turbulent flow naman, it refers to the irregular and random flow of liquid. Okay? Tandaan yan, si laminar and si turbulent. So of course, definition lang muna tayo guys, okay, for transport phenomena. But to know more about diffusion, kindly watch this video.
One of the most important processes in biology is diffusion, the movement of particles from high concentration to low. This process is passive, meaning that no energy is used by the cell to make it happen. So how does diffusion work? We will focus on simple diffusion across the phospholipid bilayer of the membrane, shown here. Notice that we have a high concentration of oxygen on one side of the membrane and a low concentration on the other side. I'm going to give you a second to think about this question. Which direction will the oxygen move? Make a hypothesis. If you said that it will move down toward the low concentration area, you are correct. Overall, molecules move from areas of high concentration to areas of low concentration. Another way to say this is that they move down their concentration gradient. But why do they do this? The answer is a bit more complex. Although we sometimes like to use analogies and say that molecules want to move from high to low, or that they like to have personal space and spread out to avoid being close to others, in reality, molecules don't really like or want anything. Instead, diffusion happens because molecules are in constant random motion. Here's a model that shows this. Check it out. Notice that the molecules move around randomly in every direction, but that overall they move from high to low concentration as they bounce around until there are roughly equal concentrations on both sides of the membrane. So the net movement is from high to low concentration until equilibrium is reached. Equilibrium is when the concentrations on both sides are equal. But notice that movement continues even after equilibrium is reached. For this reason, we sometimes call this dynamic equilibrium. Molecules are still moving, but there isn't a net movement in any particular direction. Now let's take a look at a model of a really important real-life use of diffusion, keeping you alive by getting oxygen into your blood. Take a deep breath, and we're going to look at what's happening in your lungs as a result. When you breathe in, oxygen rushes into your lungs, producing a high concentration of oxygen in your lung tissues. This oxygen can then diffuse into your blood, where it is picked up by red blood cells, which carry the oxygen away. This ensures that the oxygen you breathed in can continue to diffuse down its concentration gradient from high to low into the bloodstream, keeping you alive.
Okay, so may biochem na naman tayo, diba? Ayan, so that is guys, diffusion. Okay, and so may imagine mo lang talaga yung diffusion guys kapag sa biochem, diba? Nakikita natin siya when oxygen is being transferred to the lungs and into the bloodstream, okay? Now, the degree of random motion in a particle is generally more pronounced in smaller particles, less viscous liquids, and elevated temperatures. So, diba, sinabi natin kanina, diffusion is governed by Brownian motion. Again, it describes the random motion of particles suspended in a fluid. Dahil sa random motion nila, guys, meron silang collisions, diba? The collisions ang mga fast-moving molecules sa fluid mo. Okay? So, how can we calculate for the Brownian motion? It is through the diffusion constant T. Okay? So, as diffusion constant D is equal to RT over 6 pi over Rn and A. Okay? So, this diffusion constant R is equal to the radius of the Brownian particle, T is temperature, and the N here is your fluid viscosity. Okay? Again, guys, yung degree kasi ng random motion sa particle, mas nakikita natin siya in smaller particles. Okay? Nakikita natin siya kapag less viscous ang liquids, meaning pag less viscous, mas nagpo-flow ang liquids. Okay? Kasi yung mga particles, okay, nagta-traverse sila. Tingnan mo, specific trajectory sila based sa figure, right? And with that, they are able to engage in collisions with each other. Okay? So I hope that's clear, guys. This is the Brownian motion. Take note to guys, dahil lumalabas ito sa board exam. Okay? Specifically the concept. Okay? And of course, memorize nyo rin ang equation. Again, it describes the Brownian motion. So, makikita natin sa Brownian motion equation, it is dependent on the radius of the Brownian particle. Okay? So, if larger ang Brownian particle mo, then the diffusion constant is low. Diba? I hope it's clear, guys. Let's proceed to. Ayan. So, guys, let's answer the sample problem. Calculate the diffusion constant for a Brownian particle with a radius of 2 meters, viscosity of 0.056 Pascal, and temperature of 300 Kelvin. So, guys, you should simply just have to substitute using this equation. Okay? So, here we get 8.314, that's your universal gas constant. Your given temperature divided by 6 pi times 2 meters, given also, times 0.056 Pascal. We get 1.96 times 10 to the negative 21. Here, we related the diffusion constant to the viscosity and the radius of the Brownian particle. Okay? Now, here, let's discuss the various properties of liquids. First, with vapor pressure. So, vapor pressure, it is the pressure being exerted by the vapor in equilibrium with the liquid. Okay? And it is dependent on temperature, nature of liquid, and IMFAs involved in the liquid. Okay? Now, at the boiling point of the liquid, guys, the vapor pressure, okay, will be equal to the atmospheric pressure. What does that mean? So, guys, diba, when at boiling point, diba nagpo-form na tayo ng bubbles because that shows the formation of vapor. Okay? Yung mga bubbles na yan, makikita natin within the liquid, sa loob ng liquid. Hindi lang sa surface na, kagaya ng kumukulong tubig, hindi yan. Nasa within the liquid yung mga bubbles na yan. Now, yung internal vapor na nabuo within the liquid, okay, it must push back with enough force, so it must exert the same amount of pressure, okay, which is the vapor pressure, to overcome the external atmospheric pressure. So that will allow the boiling to occur throughout the liquid, okay? Hope that's in, guys. So here we see how vapor pressure works. So basically, guys, may mga liquid molecules dito sa baba, and then they become vaporized, na-evaporate sila, and yung mga dito sa taas, yung gas molecules nyo. Okay? Now, some of the gas molecules, they will eventually end up in the condensed phase. So, kita nyo ba guys, yung ibang gas molecules, bumabalik sila sa liquid phase. They are condensing back to liquid phase. Now, when the rate of the condensation, rate condense, is equal to the rate of evaporation, okay, then the amount of gas and the amount of liquid in your container, okay, it no longer changes. Diba? And tama naman, diba? Because condensation is continuously happening at the same rate as the rate of the evaporation. Diba? Nag-evaporate yung liquid molecules at the same rate as the condensation of the gas molecules. That's why the amount of gas and liquid, it no longer changes. Okay? Yun yung tinatawag nating equilibrium. And this is measured by the vapor pressure because it is the pressure you need para yung rate of condensation will be equal to the rate of the evaporation. So our trend is the higher the vapor pressure, the higher the temperature, and the weaker the IMFE strength. So we will go through that one by one. Okay? So first, in terms of temperature. So here, on the left, we see that there is equilibrium between gas and liquid at low temperature. Okay? Here, we see that we have fewer molecules. Fewer molecules na pumupunta sa gas phase. Diba? Fewer molecules na nag-vaporize. Okay? And this means that at lower temperature, okay, fewer molecules have no sufficient energy. Okay? Or sorry, fewer molecules lang ang may sufficient energy to escape from the liquid or solid. Konti lang ang kaya magkaroon ng condensation and evaporation. Tingnan nyo, bumabalik din sila. Then, meron din nag-evaporate, diba? Next, let's look at higher temperatures. So, at higher temperatures, guys, more liquid molecules are evaporating, more gas molecules are condensing. Okay? So, at higher temperatures, more molecules have enough energy to overcome the IMFAs. Okay? So, ang effect niyan, the vapor pressure will increase. Diba? Because you will need a greater amount of pressure in order to make the rate of condensation equal to the rate of evaporation. Siyempre guys, kung mas marami yung molecules na gumagalaw dyan, na nag-evaporate and nagko-condense, then you need more energy, you need more pressure para mag-equal ang rate nilang dalawa. Clear, guys? Okay? So let's go to IMFAs. So intermolecular forces. Recall intermolecular forces, the forces between molecules. So for example, guys, we have here ethyl ether and ethyl alcohol. Ayan. Guys, hindi na tayo mag-guess ng difference in molar mass. Okay? And this time, we're gonna look at their vapor pressure. So ethyl ether, it has a vapor pressure at 298K of 524. Then ethyl alcohol naman, vapor pressure at 298K, 754. As ethyl alcohol, it has the lower vapor pressure. Okay? And the IMFAs niya, as we know, LDF, DDI, and hydrogen bonding. Meanwhile, the ethyl ether, we have dipole-dipole interactions and LDF only. Okay? So what can we say? If the intermolecular forces between molecules are relatively strong, kagaya ng sa ethyl alcohol na may H bonding, then the vapor pressure will be relatively low. Okay? Meanwhile, if we have weak IMFAs, for example, the ethyl ether, it has weaker IMFAs than ethyl alcohol, then the vapor pressure will be relatively high. Ito kasi guys, if mas malakas ang IMFAs mo sa liquid phase, so di ba liquid muna si ethyl alcohol, then mas mahirapan siya mag-vaporize or mag-turn into vapor ang liquid nyo. Thus, bababa ang vapor pressure. Okay? Again, bababa ang vapor pressure. Next. Meanwhile, ethyl ether, okay, the London dispersion forces between the molecules there in ethyl ether, it results in a much higher vapor pressure compared to ethyl alcohol. Okay? It has weaker IMFAs. Okay? I hope gets yan, guys. Ayan. So, bakit si ethyl alcohol ang may lower vapor pressure? Because although dipole-dipole forces and LDF exist between ethyl alcohol molecules, diba, yung strong hydrogen bonding interactions talaga ang responsible kung bakit lower ang vapor pressure ni ethyl alcohol than ethyl ether. Okay? Okay, I hope that's clear, guys. And let's proceed to our next property of liquid, that is viscosity. So, viscosity measures a fluid's resistance to motion. So, when liquid flows, guys, okay, a part of it, nagmo-move siya with its neighbor liquid molecules. So, yung cohesive forces in the liquid will induce friction. Diba? Imagine you guys, cohesive forces, meaning attractive forces between like molecules. For example, okay, si water, meron siyang cohesive forces with water-like molecules. Diba? So, if the liquid has cohesive forces with the liquid, okay, that induces friction between them. And that friction will reduce the rate of the flow of the liquid. Okay? So viscosity measures that. So the viscosity is dependent on the liquid's nature, temperature, and pressure. Okay? So for example, yan. Pag sinabi natin guys, low viscosity, edi mas nag-flow yung liquid. Pero pag high ang viscosity, then there is less flow. Okay? Because we have a resistance to motion because of the friction between the liquid particles. Okay? And the cohesive forces between the liquid particles. Okay? So with that guys, what are the trends? Okay, here. The higher the viscosity, the stronger the IMFA strength, and the temperature is lower. Okay? Later, makikita natin yan. So, ang SI units, guys, ng ating viscosity ay Pascal times second. Okay? SI unit yan. And you convert that, guys, that is just equal to NS over M squared, diba? N over M squared is just your Pascal. And then, N times S over M squared can be converted to kilogram over MS. Okay? And that is equivalent to 10 posi. 10 posi. Posi ang tawag. Okay? Now, CGS unit ni viscosity ay dyne times second over cm squared. Tandaan to, guys, ha? Dapat memorize talaga to. Okay? And when you convert dyne times second, that's just equal to grams per cm times second, which is equal to 1 posi. So, guys, again, dapat memorize to in case tanongin tayo ng mga conversion. Okay? So, ang posi, guys, ganito siya. Capital P. Capital P, ang unit ni posi. Poise. Yan. Okay? Okay, I hope that's clear, guys. Now, let's proceed. So, this relates viscosity and temperature. From this figure, guys, you see that, okay, yung water, it spreads out easily. Pero pagdating natin sa silicon sealant, sa honey, okay, they are more viscous. Therefore, they stay put even after it is dispensed. Okay? So, temperature can affect the viscosity of various compounds. Okay? However, guys, take note that temperature and viscosity, they are inversely proportional. Okay? Meaning, if you increase the temperature, increase mo ang temperature. Therefore, mag-increase yung kinetic energy ng liquid particles mo. So, the easier for the liquid particles to flow. Right? Meanwhile, if you increase mo yung temperature, okay, then the kinetic energy of the particles will decrease. So, the less likely the molecules will flow. Therefore, okay, for a higher temperature, we have a lower viscosity. Okay? Therefore, gets, guys? Sorry, again. Therefore, for a lower temperature, we have a higher viscosity. Diba? More viscous kapag mas maliit ang ating temperature. Okay? I hope that's clear, guys. Diba? Kasi viscosity, it is being really measured in a lot of industries. Okay? So, ginagamit din siya in measuring the viscosity of fuels. Mineral fuel oil, ethanol. Diba? Also in brake fluid, antifreeze, mercury, sulfuric acid, etc. It is very helpful. Kaya important siyang element. Okay? And share ko lang guys, nagamit ko din tong viscosity when I was working as a product development analyst. We always measure the viscosity of lotions, okay? Ayan, hand soaps. Tapos, it really tells us a great information about the product we have formulated. Diba? And we can actually control the viscosity of various products, okay? Through a lot of ingredients that increase or decrease the viscosity. So viscosity is a really interesting topic, guys. Okay? Take note of that. Now, these equations here shows the equations on determining the viscosity of liquid. So we have 3 equations, guys. We have to memorize this, okay? Baka lumabas sa board. So usually, guys, yung lumalabas sa board ay itong first 2 equations, okay? So for the first equation, guys, the Hagen-Poiseuille equation, it describes the viscosity of a fluid as it flows through a capillary tube. Guys, ang capillary tube nyo, it is narrow, right? So again, it describes how viscosity affects the fluid flow through a narrow capillary tube and shows that the flow rate, okay, is inversely proportional to the viscosity. Okay? So ito yung viscosity, yung N dito. And ito ang volume ng liquid. Again, hindi to viscosity, this is volume ng liquid. Okay? So the higher the viscosity, okay, the slower the flow. Ayan. So the equation is V is equal to pi times pressure times the radius of the capillary tube to the power 4 times the flow time divided by 8 ln. So L is your length of capillary tube, viscosity ang N. Okay? So how do I memorize this? V is equal to pi prat over 8 ln. Next we have the A-rings theory. Second, the A-rings theory, it connects viscosity with temperatures. On point lang yan guys, kinoconnect niya ang viscosity, si N. Hindi yan. Si N, to, with temperature. And yun yung purpose ng A-rings theory. So it treats flow as a rate process. So parang pag nagflow daw guys ang isang liquid, rate process yun. Okay? So sa rate process kasi guys, kailangan may ma-overcome na energy barrier ang molecules mo, 'di ba? Ma-overcome niya ang activation energy, 'di ba? Okay? So the A-rings theory is delta G naught is equal to RT ln times Mn over H times the Avogadro's number times the density of liquid. Okay? RT ln Mn over H snap. O H snap naman, snap, 'di ba? Pag snap, A-rings. Pag pi prat, Hagen. Okay? Kaya guys. Okay? So notice mo ba guys, meron tayong various viscosity equations, pero depende ito on kung saan natin sila i-apply. Okay? Again, Hagen-Poiseuille sa mga capillary tubes. Okay? And lastly, for Markov equation, okay, it relates the viscosity, so intrinsic viscosity ang tawag dito guys, intrinsic velocity to the viscosity of polymer solutions. So special lang ito sa polymer solutions. Okay? Tapos nirelate nila ang viscosity na yun sa molecular weight. Yun. Okay? Ayan. Then, so for the Markov equation, yung K is the solvent concentration dependent constant. So constant lang siya. Tapos si A naman, it is the polymer geometry dependent concentration. So A could either be 0.5, okay, which means it is well coiled. Pag 1.7 naman meaning rigidly extended. Okay? Yung inyong liquid. Again, A must be equal to 0.5 meaning well coiled siya. Pag 1.7 naman meaning rigidly extended yung inyong liquid or yung viscosity ng liquid. Okay? I hope it's clear guys. Okay? Now, with that, let's answer the sample problem. What is the viscosity of a liquid flows through a capillary tube with a length of 10 centimeters and diameter of 0.5 millimeters at a rate of 1.5 milliliters per second at 1 atm? So, guys, we have here the clue, capillary tube. So, yung gagamitin natin equation ay yung Hagen-Poiseuille. So, first, guys, let's find the volume, which is milliliters divided by second. Okay? Ganyan. Okay? So, make sure natin, guys, na again, in SI units. Para sure ball tayo na in SI units ang ating viscosity value. Okay? So, ang gagawin ko lang dito, guys, itong V over T, retain ko lang yan. Tapos, i-convert ko lang si ml to m cube. Again, this is your SI unit. So, V over T is equal to 1.5 ml over S times convert ml to liters, and then convert liters to m cube, meters cube. And then lastly, you have your answer. 1.5 times 10 to the negative 6 cubic meters over second. And then now we can solve for the viscosity of a liquid through the Hagen-Poiseuille equation. Again ha, ang inyong viscosity ay si N, okay? Yun nasa denominator. So N is equal to pi prat divided by 8 times L times V. So again, V here, the capital V is your volume for the liquid. So solving, notice guys, yung T nyo nasa numerator. Okay? Alam natin na V over T. Ito, di ba? Ano mangyayari guys? Pwede ko tong ilagay sa denominator. Okay? Because pi prat times LV times 8 LV, it is just still equivalent, di ba? To pi pra, okay, divided by 8L times V over T, di ba? Pag binalik mo to sa numerator, same pa rin yung value, okay? So, substituting we get pi times 1 atmosphere times convert to Pascal ulit para sure tayo na SI units yung lalabas, okay? Times, okay, the radius. This is the radius, guys. 0.25 times 10 to the negative 3 meter to the power 4. Bakit 0.25? Because here we are given the diameter, so kukunin lang natin ang radius. Very good. And divided by 8 times 10 times 10 to the negative 2 meters, so ganito siya i-solve, okay, of course. Okay? So, ito yun, given din ang ating length. This time, yung centimeters, convert to meters. Notice, guys, lahat naka-SI units. Times V over T. So this is what we solve for here. Solving for the viscosity of a liquid, we get, ayan, 1.04 times 10 to the power of negative 3 Pascal times seconds. Diba? Ito ang SI unit natin, kay viscosity. Therefore, we are consistent with our units. Now, guys, let's convert this Pascal times seconds to POSI, yung POISE. So, tandaan, guys, 1 Pascal times second is just equal to 10 POSI. Okay? 10 POSI. So, convert na natin. So, cancel na ito. Cancel. And then convert 1 POSI to centipoise. Centipoise, kumbaga. So, cancel. Diba? Kasi centipoise naman. Diba? Ang ating gustong makuha. So, solving, we get 1.04 centipoise or centipoise. Okay? Is that clear, guys? Good. Now, let's watch this video on how we can determine the viscosity through viscometers. So, viscometers, guys, they measure the viscosity of liquids. We have 3 basic types. First is the Oswald viscometer. So, it measures the flow time between 2 marks under gravity. So, may mark yung apparatus nyo. And then, the Cannon-Fensky viscometer, okay? Meron siyang inclined design, inclined, and second reservoir. And this reduces the effects of pressure. And lastly, for high viscosity liquids such as that of polymer solutions, diba? Kasi very high viscosity yan, meaning it is harder to break the IMFAs between them. Then, the Oberlode viscometer provides great accuracy. Again, Oberlode viscometer for polymer solutions. Okay? Pero ngayon, syempre guys, meron tayong tinatawag of digital viscometers. Okay? So here guys, please watch this video.
Viscosity measurement. All fluids, liquids and gases exhibit a characteristic property of flowing under an applied force, which could be even the force of their own weight, and also the ease which they flow differs from the liquid to liquid. The property of resistance to flow when a stress is applied to a liquid is called its viscosity. Here, aim is to find the absolute viscosity and the unknown composition of a given mixture. Now the apparatus used: watch bottle, stopwatch, Ostwald's viscometer, unknown liquid, pacnometer or RT bottle, pipette, a vein balance. Ostwald's viscometer is a traditional viscometer to measure the viscosity of a liquid. It is a U-shaped glass tube. In one arm, the bulb A is connected with a fine capillary. The lower end of the capillary is connected with a U-tube provided with the bulb B in the second arm. The bulb B is necessary to maintain the hydrostatic pressure during the flow of liquid. Through the capillary tube, the liquid flows with measurable speed. There are two marks, C and D, above and below the bulb A. The liquid flows under its own weight. The density of liquid is determined either by picnometer or by RT bottle. Now the procedure. Clean the viscometer with chromic acid and then wash thoroughly with distilled water. It is then washed with alcohol or acetone and dry. A sufficient volume of distilled water is introduced by pipette in bulb B so that the bent portion of 2 and half or a little more than half of bulb B are filled up. Clamp the viscometer in quite a vertical position. Using the pipette pump, suck up water until it rises above the upper mark C and allows it to flow under its own weight. The time of flow of water from C to D is counted by starting the stopwatch as the meniscus just reaches the upper mark C and stopping the watch as the meniscus just passes the lower mark D. Take at least 3 or 4 readings with water and then take the mean of them. Now remove the water from viscometer and dry it. Introduce in bulb B the same volume of liquid and measure the time of flow of liquid as before. Take at least 3 or 4 readings and then take the mean value. Now wash and dry the picnometer or RT bottle and then weight it empty. Then fill it with more distilled water and weigh. Remove water and dry. Then fill it with experimental liquid and weigh. Note the room temperature also. Thus, the absolute viscosity of a given liquid can be found out using the formulae. Similarly, the unknown composition of a given mixture can also be found by plotting a graph time of flow in seconds versus composition of given mixture.
Ayan, so now, we know how to determine the viscosity to the Ostwald viscometer. So, nagamit ko yan sa lab, guys. Actually, never ginagamit sa lab. Pero, nung nag-work pa ako sa R&D lab, I got to experience how to use a digital viscometer. It's much easier, guys. You just have to find the correct spindle. So, yung spindle na yan, it's a spindle, like parang siyang stick. Tapos, yun yung mag-mix around, mag-rotate siya around your sample. Okay? Tapos, you have to find the correct RPM. So, syempre, yung spindle na yan, mag-rotate siya at a specific speed. So, you have to find the correct spindle and the correct RPM. Okay, for you to get the correct viscosity measurement. So here, guys, this demonstrates the digital viscometer.
This is a viscometer, and we use it to measure the viscosity of our products in the lab. Today, we'll compare two products with very different viscosities. First, we have a thin conformal coating, so we chose to use a large spindle and a high RPM. We submerge the spindle into the product and then turn the motor on. The viscometer displays the viscosity value measured in centipoise or CP and the torque percentage. The torque percentage is specific to the spindle and RPM, but the CP value can be compared across products. Here, it's about 167. For the Piper coating compound, a small spindle and slow RPM were chosen. The CP this time is around 90,000, which is significantly higher than the conformal coating.
Ayun, very cool, right? So that is your digital viscometer. Now, with that, did you know? So did you know the pitch drop experiment on viscosity is the longest running experiment? So at the University of Queensland, okay, meron silang experiment in 1927 which uses a star-like substance we call the pitch. And the pitch, it demonstrates extreme viscosity. Okay? So kahit solid siya, mukha siyang solid, diba? It's actually a very, very, very slow-flowing liquid. It takes about 8 years for a single drop to fall. Okay? And in just nearly a century, only 9 drops have fallen. So guys, tingnan nyo nga tong video na to. Okay? So time-lapse ito ng pitch drop experiment in 3 years. Very slow yung flow. O yan na siya ulit. Kasi nag-drop na yung 9th drop. May magawa ng drop dyan. Diba? So cool. Ayan. So, diba? It turns out to be, diba, very hard solid siya. Pero, turns out, very slow flowing pala siya. Okay? Now, let's move on to our last property of liquids. It is the surface tension. So, the surface tension, it originates from the IMFAs of liquids. Okay? Because the factors affecting surface tension are the nature of liquid, the IMFAs, the temperature, pressure, and added solute. So, let's define surface tension first. So, it arises from the unbalanced inward pull on the molecules of a liquid surface. Kaya, dahil dyan, yung surface, mag-act siya like a thin stretched membrane and will create a tightening effect we know as surface tension. Okay? So, here, the bulk molecules, guys, diba, they are pulled from all directions. Right? Bulk meaning within the liquid. However, yung surface molecules, no, they're only being pulled inward. So, the pull of the molecules is unbalanced because meron tayong pull inward. Yan ang ating surface tension. So, you can also view it this way. Again. So, here we have the surface tension. Okay? Meron tayong tightening effect na nangyayari. Diba? Sa ating surface. Because there is an inward pull of the surface molecules. Inward, papunta sa bulk. That is your surface tension. So, ang SI units na ating surface tension ay J over M squared, which is equal to N over M. Again, it is N over M. CGS unit, it is erg over CM squared, which is equal to dyne over CM. Dapat memorize din ang CGS. Okay, guys? So, the important conversions, please take note. 1 Newton is equal to 10 to the power 5 dyne. And 1 joule is equal to 10 to the power 7 erg. Okay? I hope that's clear, guys. So, guys, ang symbol for surface tension ay gamma naman. Gamma. Okay? So, guys, to learn more about surface tension, kindly watch this video, please.
What is surface tension? To understand surface tension, let us consider a vessel filled with water. Let us assume that water molecule A is present somewhere near the center of this vessel. And water molecule B is present at the free surface of water. We see that molecule A is attracted equally in all the directions by the surrounding water molecules. Thus, the net intermolecular force acting on A will be 0. We also see that molecule B is attracted by the water molecules present below it. As the attraction on B is unbalanced, so a tensile force acts on it in the downward direction. Similarly, this tensile force will act on all the water molecules present on the surface of the water in the downward direction.
due to the net unbalanced intermolecular force between the water particles. This tensile force is known as surface tension. Thus, surface tension is the tensile force acting on a free liquid surface due to the unbalanced intermolecular forces. Some of the applications of surface tension are liquid drops, liquid bubbles. Note that, due to surface tension, liquid drop and liquid bubbles are spherical in shape. Related term is capillarity. Question. Remember keywords. Related term is remember diagram.
Ayan.
Remember definition.
So guys, that ends our brief video on surface tension. So again guys, meron tayong surface tension kasi unbalanced yung pull sa ating surface molecules. Nasa surface lang sila guys, so it only experiences inward pull papunta sa bulk. Okay, that's why it has unbalanced IMFAs. Therefore, meron siyang net tensile force na papunta sa baba, di ba? Because the surface molecules are being pulled inwards. Okay, and that is what we call the surface tension. Okay.
What is
Ayan. So the methods of surface tension determination are summarized in table 26. So there are 3 types. First is the capillary rise method. Okay. So ang nangyayari dito, okay, when a narrow tube, example ito, narrow tube, is inserted to a liquid like water, okay, surface tension, it pulls the liquid upward. Okay? Parang i-insert mo yung narrow tube, tapos i-insert mo siya sa water. Yung surface tension mo, mapupull siya, ipupull niya yung liquid upward. Okay? Kaya may mapaform kang concave meniscus. Ito. Okay? So, the higher the surface tension, the greater the capillary rise. Okay? Ito yung tinatawag na capillary rise kung tataas yan. Okay? Tandaan yan, guys. So, this principle helps measure surface tension by observing how high the liquid will rise. Okay? So, the equation is gamma, which is your surface tension, is equal to the density times this gravitational force times the capillary rise H times the capillary rate. So again, capillary tube na naman ang capillary rise method. So again, this equation is only applicable to capillary tubes. So completing the equation divided by 2 cos theta. So theta is the contact angle. So usually guys, kung hindi naman given ang contact angle, okay, hindi natin ito i-consider. Magiging gamma is equal to PGHR over 2 na siya. Next, we have the bubble method. So at the bubble method guys, okay, meron tayong form na bubble. Tapos yung bubble, okay, for example ito, ayan, that bubble will form at the end of a capillary tube. Nasa end siya ng capillary tube when you apply a pressure para ma-push mo yung fluid out, diba? Kaya may bubble sa end ng capillary tube. Okay. Now, this pressure, yung applied pressure para malabas mo yung fluid, it must overcome the hydrostatic pressure, okay, and the surface tension. Again, yung pressure na i-apply mo in order to push the fluid out of the capillary tube, okay, it must overcome the hydrostatic pressure and the surface tension. Okay? And that resists the formation of the curved bubble surface. Okay? So, bakit kailangan natin guys mag-apply ng pressure, okay, to form the bubble? Kasi yung hydrostatic pressure and yung surface tension nyo, okay, it resists the formation of the curved bubble surface. So, the equation for that is surface tension gamma is equal to the change in the differential pressure, okay, times R, the radius of bubble, divided by 2. So we get the differential pressure in order for us to know how much applied pressure we need in order for the bubble to form. Okay? And then lastly, we have the drop weight method. So in the drop weight method, nakita niyo ba sa baba? Okay? So at the lower end of a capillary tube, meron ka namang na-form na droplet. Diba? Capillary tube ulit, for this time, you're gonna look at a certain drop sa end, sa tip ng inyong capillary tube. Now, yung drop na yan, nasa tip lang siya ng capillary tube and it will be held in place by surface tension acting along the tube's edge. Kunwari, meron kang tube. Okay? May tube ka. Now, kaya lang nagsistay dyan yung drop because of surface tension. So when the droplet, it becomes heavy enough to overcome the upward force, okay, due to the surface tension along the tube's edge, magdedetach yung liquid drop. Okay? Now, measuring the mass or the weight of the droplets will give us a way in calculating the surface tension. So the surface tension gamma is equal to mg, so mass of drop, times the gravitational force divided by 2 pi rf. So r, radius of capillary, and f, the correction factor. Okay? So guys, usually sinasabi naman yung correction factor, but if not, you assume 1. Okay? Ayan. So again, this only applies to drop weight method. So kunwari guys, yung tanong sa problem, a bubble is formed in a capillary tube, ganun. So matik guys, ang gagamitin yung equation ay yung second equation, yung equation for bubble. But what if guys, sabi naman, in general, capillary tube, like may nag-rise na liquid in a capillary tube. Then you use the capillary rise method equation, this one. O paano naman guys, meron daw nag-form na drop. O, keyword drop. Then you use the surface tension equation for the drop weight method. Okay? Yan. So, let's try the sample problem together. What is the surface tension of a liquid? Density is equal to 0.83 grams per milliliter in a capillary tube with a diameter of 1 millimeter if it rose 3 centimeters from the initial liquid surface. O guys, anong clue natin dito? Yung liquid, nag-rise siya 3 centimeters from the initial liquid surface. So yung gagamitin natin na equation ay the capillary rise method equation. Okay? Because here we have the term rose. Liquid rose. Okay? So first guys, ang gagawin ko is to convert the density of the liquid to SI units. Okay? Para consistent. So density is equal to 0.83 grams per milliliter times, I convert grams to kilograms. Okay? So guys, take note, 1,000 kilograms per meter cube is just equal to 1 grams per milliliter. Okay? Ito lang siya. So guys, you can memorize this for easy reference. So this is equal to density is equal to 830 kilograms per cubic meters. So now we can solve for the surface tension using the capillary rise method. So we just have to simply substitute the value. So 830 kilogram per cubic meters, this is your density, times the gravitational force, okay, times 3 times 10 to the power of negative 2 meters. Okay, this is your what? Your height, right? Next we have your radius, 0.5 times 10 to the negative 3 meters, divided by 2. Guys, wala tayong given a contact angle, therefore cos theta is just equal to 1. So solving, we get 0.061 N over M. Again, guys, this is the SI units for surface tension, N over M. Okay. Now, let's proceed to the factors affecting surface tension. So the Katayama equation, it relates surface tension with temperature. Okay. So as temperature increases, surface tension decreases. Okay. Bakit? Because meron tayong increasing kinetic energy, diba, of the molecules as temperature increases. So that weakens the IMFAs. Dahil dyan, yung surface tension natin ay nagdi-decrease. Okay. the inward pull of your bulk will be decreased. Okay? So, no need to memorize the Katayama equation, okay? This just shows us that temperature is related to surface tension, okay? And as you can see from this graph, as temperature increases, the surface tension decreases, okay? Next, we have in terms of IMFE strength. So here we have pentane and water. Ang surface tension ni pentane ay 15.59 over cm, kay water naman it's 72.89 over cm. So my higher surface tension I see water, which has hydrogen bonding. Pentane only has London dispersion forces. Therefore, we can say that as the stronger the IMFE strength, the surface tension increases. And that is because the molecules at the surface, okay, they experience stronger cohesive forces, diba? Yung mga water molecules, they have stronger cohesive forces with your other water molecules. At dahil dyan, napupull sila inward. Okay? Napupull sila inward. Okay? Ng mga molecules at the bulk or within the liquid water. Okay? I hope that's clear, guys. Ayan. Now, we have our last factor affecting surface tension. So here we have the Gibbs isotherm, and it relates surface tension with concentration of added solute. Okay? So, again, guys, what is surface excess concentration? Pag sinabi natin surface excess concentration, it is a measure of how much solute accumulates at the surface, kung ilan yung matitira sa surface compared to the bulk. Okay? So, we can determine that through this equation. Okay? So, mu is your surface excess concentration. Tapos, your gamma is your surface tension. Okay? Okay? So, let's analyze. Ayan. So, guys, sabi dito, if mu is positive, then dapat the surface tension is also what? Negative yan. Negative yung change in surface tension, right? Para maging positive ang value nito. Kasi dapat positive ang inyong surface excess concentration, right? So, if you have a positive surface excess concentration mu, then your surface tension decreases. And this is common for organic compounds and surfactants. Okay? Bakit? Kasi guys, yung solutes na yan, they will reduce the cohesive forces between the surface molecules. Okay? Again, they will reduce the cohesive forces between the surface molecules. That's why the solute, they will stay on the surface. And they will disrupt the cohesive surface forces. Okay? Mabida yung mga solute dyan. Kaya positive si mu. Okay? Because the solute will just stay on the surface. And as a result, because your cohesive forces, break apart mo siya, disrupt mo siya, the surface tension will decrease. Okay? Next. Again, this happens for organic solutes. Okay? As well as surfactants. Okay, kita niyo dito guys, nagdi-decrease ang ating surface tension as we increase the concentration of the component I, or we increase the concentration of your solute. Okay? Ayan, next, we have, what if naman negative ang mu? Negative ang ating surface excess concentration. Negative to. So, dapat positive to, di ba? Dapat positive ang change in surface tension. Therefore, if negative ang ating surface excess concentration mu, then gamma, your surface tension, must increase. Okay? And this usually happens for inorganic salts, inorganic electrolytes. Okay? Kita nyo guys? Diba? Nag-i-increase ang kanyang surface tension as we increase the concentration of your added solute. Okay? O bakit? Because these solutes guys, they do not prefer the surface. Gusto nilang magstay in the solution. Kaya negative ang value natin for the surface excess concentration. Kasi gusto nilang magstay on the bulk, not on the surface. Okay? So ano mangyayari sa surface ng water molecules mo? Or sa water molecules mo sa surface? Kunwari, ito yan. Ito yung water molecules mo, tapos nandito yung mga inorganic electrolytes mo. Ito yung inorganic electrolytes. Again, they will stay in the bulk. So, yung water molecules mo on the surface, they will be left undisturbed. Hindi sila madidisturbo. So, they will stay more structured. Therefore, hindi nasisira yung ating cohesive forces sa ating surface. Therefore, surface tension increases as you increase the concentration of your added solute, which is in this case, the inorganic electrolytes. Okay? Again, guys, pag ang added solute mo ay organic or surfactant yan, they would rather stay on the surface. So, i-disrupt nila yung cohesive forces between the water molecules here. They disrupt nila yan. That's why the surface tension will decrease. I hope it's clear, guys. No, this just summarizes what I said earlier. Okay? Ayan. To know more about how surfactants affect the surface tension, kindly watch this last video.
Hello and welcome to my channel Pharmacy in Depth, where we'll talk about pharmacy-related topics in detail. Today we will see what are surfactants, how they help to stabilize the system, and what are their applications. So based on solubility, some material dissolve in water and some material dissolve in oil. The materials which dissolve in water are called polar, hydrophilic, or lipophobic materials, and the ones which dissolve in oil are called non-polar, hydrophobic, or lipophilic materials. A surfactant molecule has both a component, a polar head and a non-polar tail, and that is why it is called amphiphilic in nature. Because of this nature, it is able to dissolve itself in water as well as in oil. When added to water, it aligns itself in such a way that the polar head is in contact with water and the hydrophobic tail is away from the water. And similarly, when added to oil, it aligns itself like the hydrophobic tail is in contact with oil and the polar head is away from the oil. When this oil is added to water, it forms oil in water emulsion. In that emulsion, surfactant molecules align themselves at the interface of oil and water in such a way that the polar head is towards the water and the hydrophobic tail is towards the oil phase. And this is how it stabilizes the emulsion. The mechanism by which a surfactant stabilizes an emulsion is by reducing the surface tension at the interface. So now let's see what is surface tension and how a surfactant reduces the surface tension at the interface. Water molecules, which are in the bulk of water, experiences a force of attraction from other water molecules, but this force of attraction is equal in all the direction, and hence the resultant force on each water molecule is zero. But the water molecules which are present on the surface of water experiences a force of attraction from all the direction except from the top. Since the force is equal, the sideways force is balanced out, and they experience a net resultant force of downward pull. This creates a tension on the surface of water, which is known as surface tension. It is because of this surface tension we see the spherical globules of water, because the spherical shape has the smallest surface area. Now let's see how a surfactant molecule helps in reducing the surface tension. So when a surfactant molecule is added to water, it aligns itself that the polar head is in contact with water, and hydrophobic tail moves away from the water surface. There are two mechanisms by which a surfactant reduces the surface tension. First is because the head of a surfactant is polar in nature, it attracts water molecules towards it. As a result of this attraction, the downward pull which is experienced by the surface water molecules is reduced, and hence the surface tension reduces. The second mechanism is that the surfactant molecule has a hydrophobic tail which is trying to move away from water, so it exerts an upward force which balances out or which reduces the net downward force experienced by the water molecules on the surface. As a result of which, it helps in reducing the surface tension. So as the number of surfactant molecules in the system increases, the surface tension also reduces. Based on the charge present on head of a surfactant molecule, it is classified into 4 types. First is non-ionic surfactants, which don't have any charge. Example is tritium X100. Second are cationic surfactants, which have a positive charge on the polar head. Example is CTEP. Then are anionic surfactants, which have a negative charge on the polar surface. Example is diethyl sulfosuccinate sodium. And the fourth type is deuterionic surfactants, which have a positive as well as a negative charge on the head. Example is phosphatidylcholine. These different types of surfactants have different applications. Like cationic surfactants are used to treat burns and wounds because of their excellent disinfectant and bactericidal properties. Anionic surfactants are used in pre-operative skin cleaner and medicated shampoos because they also have bacteriostatic activity. Deuterionic surfactants have an excellent dermatological properties, and non-ionic surfactants are used as a nanocarrier like niosomes, liposomes, and polymerasomes in pharmaceutical applications. Other than pharmaceuticals, surfactants have a wide range of applications, like they are used in personal care, household care, textile auxiliaries, institutional cleaning, emulsion polymerization, agriculture, and oil and gas industries. So guys, this was all about surfactants, different types of surfactants, how a surfactant reduces the surface tension, and different applications of surfactants. Thanks for watching the video.
Ayan guys, so now you know how surfactants affect your surface tension. Actually, sobrang daming uses ng surfactants, right? Okay. So personally, nagamit ko din yan during my time as an R&D analyst. Diba? Again, we use surfactants to decrease the surface tension. Okay? And in turn, the surfactants, they stabilize emotions. Ma'am, saan natin nakahanap yung emotions? So later on, when we get to colloids, to our next topics, we will discuss emotions. Okay?
Hello and
Ayan. So this summarizes the equations we used for the liquid state. Again, we discussed the equation for Brownian motion. Diffusion constant is equal to RT over 6 pi Rn times the Avogadro's number. Hagen-Poiseuille equation. Okay? So this is for the viscosity of a liquid in a capillary tube. And then Airy's theory, also for calculating the viscosity. Capillary rise. Okay? So this is used in calculating for the surface tension as a liquid rises in a capillary tube. Surface tension of a bubble that formed in a capillary tube. And lastly, we can calculate for the surface tension of a drop that formed at the end of a capillary tube. Ayan guys, so patapos na tayo. So now, let's answer these. Go nga. So yes, the first one, it refers to the random and continuous motion of particles or molecules suspended in a liquid. Ano yan? Yes, that is Brownian motion. Next, pressure exerted by the vapor in equilibrium with the liquid. Ano kaya yan? Yes, that is vapor pressure. Next, it measures a fluid's resistance to motion. Yes, that is viscosity. Next, this equation describes the viscosity of a fluid as it flows through a capillary tube. Hagen-Poiseuille equation. Lastly, it arises from the unbalanced inward pull on the molecules of a liquid surface, causing it to act like a thin stretched membrane. Surface tension. And yay, congratulations guys, we are done with crash course 6. Okay? And now you may answer practice test 5. So guys, we are done with gaseous state for today and liquid state.